we simplify rational expressions. But before we get to the rational expressions, we need to define what on earth a rational number is. Rational numbers are better known as fractions, or mathematically we can call them the quotient of two integers where the denominator is not zero. Just like rational numbers, rational expressions are the same sort of idea, but now we're going to introduce variables into the expression. So 2x minus 3 divided by x squared plus 1, that is a quotient of two things, but now we have variables inside of them. So we call that a rational expression. Again here, let's remember that for a rational number and a rational expression, the denominator cannot equal 0. And this is going to become important when we look at simplifying. We can see here a couple of other rational expressions like 1 over x, y minus 4 over 7, and x squared plus 3x minus 1 all over x plus 7. Sometimes we'll have just numbers, sometimes we'll have just variables, or we could have a combination of both in the numerator and the denominator. Okay, so how do we simplify? Well, let's start with an easy example. 25x squared y divided by 5xy. This is considered a rational expression because we have variables and coefficients in the numerators and denominators. Notice how we don't have any addition or subtraction, though, in either the numerator or denominator. This makes our lives much easier when solving and simplifying, as we can just reduce the coefficients with each other and reduce the variables with each other as well. Start with the coefficients. 25 and 5, well, since we're dividing, those can simplify to 5 and 1. X squared and x, well, as we know by exponent rules that when we have an exponent 2 divided by an exponent 1 on this x, we subtract the exponents. In other words, we're going to get rid of 1x on top, 1x on the bottom, and be left with just one singular x in the numerator. Finally, these y's can simply cancel with each other as we have 1y and 1y. So what we're left with here is 5x in the numerator and only 1 in the denominator, which I'm not even going to bother writing. So our answer here is 5x. But remember before how we said that rational expressions only exist when the denominator cannot equal 0. Well, if we look at our original denominator of our question, 5xy, what values of x or y would cause that denominator to have equaled 0? Well, notice that if either x or y were 0, then this whole denominator would have equaled 0, because 5 times 0 times any other number equals 0. And we can't have a denominator equal to 0. So we would say that those would be restrictions. We're going to say that x and y cannot equal 0. And again, our reason is because in our original denominator, if either x or y equaled 0, this entire denominator would have multiplied to become 0, which we can't have. Alright, now here's an example where we don't just have multiplication. We actually have some subtraction going on in the denominator. So we're still asked to simplify and then state any restrictions for x. Remember, we want to figure out for the restrictions what values of x would cause the denominator to equal 0. And we'll get to that when we get towards the end of the question. But first we need to simplify this rational expression. Now, the common mistake that we often see when simplifying here is to simply reduce coefficients with coefficients you see on numerator and denominator. So for example, let's take this 4 and reduce it with this 12, and this would turn into 1 and this would turn into 3. Do not do this. This is incorrect. It's all wrong. Okay? Don't do this common mistake. We cannot simplify those things just like that because we have this subtraction that's going on in the denominator. That subtraction is preventing us from reducing top and bottom. We have to act like there's these hidden brackets that are in this denominator, and this action of subtracting this 16x cubed and this 12x has to happen before we could cancel on anything with the numerator and denominator. So before we can cancel anything top and bottom, we need to do something with the denominator. And what we are going to do actually is factor. anytime we have a expression in the numerator or denominator where we're adding or subtracting, we need to look to see if we can factor into 2 or 3 different factors so that we turn it into multiplying and dividing. So looking at this denominator, we're going to leave the numerator at 4x. The denominator of 16x cubed minus 12x, we first want to look for a common factor. 16 and 12 have a common factor. Their common factor is 4. And x cubed and x also have a common factor. Their common factor is an x. So in brackets beside it, we write what's left over. 16x cubed divided by 4x, we're left with 4x squared. And negative 12x divided by 4x, we're left with negative 3. So now we have 3 different things that are all multiplying and dividing. We have this 4x in the numerator, 4x in the denominator, and a 4x squared minus 3 in the denominator. All 3 of those are multiplying and dividing. So we can cancel and reduce anything that is multiplying and dividing. This 4x and this 4x, they're exactly the same. Those would cancel and reduce out with each other, both becoming 1. This 4x squared minus 3 now is all alone in the denominator. So we have our final simplified expression here of 1 over 4x squared minus 3. Now we need to state the restrictions. The rule of thumb here is, because we're not only restricting on our final answer, 4x squared minus 3, it's true that can't equal 0. So we need to figure out values of x which would make that equal 0. But we also need to make sure that at any point in the question, the denominator did not equal 0. So the rule of thumb is to look at the point in the question where we've been simplifying prior to us canceling. And that happens right in this line right here. We're going to look at this 4x bracket 4x squared minus 3. Because it's nicely factored for us, it's easier to read. And we want to figure out what values of x here will make this equal 0. We actually want to make this denominator equal to 0 off to the side, because we want to figure out what values of x we don't want to have in our question. So by making it equal to 0, we're going to solve for what values of x would make it 0, and then we're going to say that those values will be restricted. Well, we have 2 chunks here that are multiplying to each other, and we need this to equal 0. So really, if this chunk or if this chunk equaled 0, this whole thing would equal 0. So what value of x would make this equal to 0? Well, that x would have to equal 0 for that to equal 0, because 4 times 0 is 0. Well, what about here? 4x squared minus 3. How do we make this equal to 0? Well, that's a little tougher to see right offhand, so I'm actually going to write this separately as an equation. 4x squared minus 3, we want that to equal 0. So let's rearrange and solve. Move down a bit here. 4x squared minus 3 equals 0. Let's move that 3 over and then divide by 4. So we'll have x squared equals 3 over 4. Now to get x by itself, we need to square root. So we're going to square root both sides. We're left here with x is equal to the square root of 3 over 4. Now another thing we need to remember is anytime we force a square root when we're trying to isolate for a variable, it means that we need to not only take the positive version, but also the negative version. So this is plus or minus the square root of 3 over 4. We've already learned in this course that we can simplify this even a bit further. So remembering that a radical sign over a fraction is the same thing as writing that radical sign over the numerator and over the denominator. So root 3 over 4 is the same thing as root 3 divided by root 4. This helps us simplify because we actually know what the square root of 4 is. The square root of 4 is 2. So our final answer here for what x will equal is plus or minus root 3, and then the square root of 4 is 2. So we have our restrictions here. One restriction is that or we have x equals 0 and x equals plus or minus root 3 over 2. Both of those are values for x that need to be restricted on our final solution. If x is any of those values, this whole thing becomes undefined because the denominator equals 0. So in our final answer, we're going to say our simplified rational expression is 1 over 4x squared minus 3, but x cannot equal 0 or plus or minus root 3 over 2. So we'll say plus or minus root 3 over 2. And we're not going to make this into a decimal. We're going to keep this as an exact value. And we have 3 different restrictions: the 0, the positive root 3 over 2, and the negative root 3 over 2. Here's another example where we're going to need to factor. Let's simplify 3 minus 2x over 4x minus 6. Again, a common mistake here, or something that everyone wants to try to do, is just to reduce this 3 and this 6, or reduce this 2x and this 4x. But we cannot do that because of these subtraction signs. It's preventing us. So we need to factor. One thing we can look at in the denominator is we do have a common factor. Both 4x and 6 are divisible by 2. So we can rewrite this as 3 minus 2x all over, and common factor at 2, 2x minus 3. Well, looking at all these things here, this numerator, this 2, and this 2x minus 3, none of those things are exactly the same. The 2 cannot cancel with this 2 or reduce because of the subtraction sign. And the 3 minus 2x isn't the same as the 2x minus 3, but they're pretty close. In fact, the only difference is that in the numerator, the 3 is positive and the 2x is negative. Whereas in the denominator, the 3 is negative and the 2x is positive. So really the only difference is a negative 1. So one little hint here is, well, if you have a situation where you have the same numbers, but they're sort of flip-flopped, with one being negative, one being positive, a trick here is you can factor out a negative 1. We're going to factor out a negative 1 from the numerator. So take out a negative 1. All that means is divide both things by negative 1. So 3 divided by negative 1 is negative 3. Negative 2x divided by negative 1 is positive 2x. And hopefully you can see here that that will equal the same thing that's in this denominator here, 2x minus 3. We have a negative 3 and a negative 3. We have a 2x and a 2x. I could rearrange this to become the same thing as the denominator, which means that now we can fully cancel them. They're the exact same thing. They can fully reduce. And all we're left with here is this negative 1 over 2. You're not quite finished yet. We do need to state the restrictions. And I know that this final answer has no x's in it. So it doesn't look like there are any restrictions. How on earth could we make this question or this rational expression equal to something undefined? How do we make the denominator equal to 0? Well, we need to look at the spot prior to us canceling, which was this line right here. And we notice that inside the brackets here, this 2x minus 3, we can find a value there that will make this denominator equal to 0. Because if this bracket 2x minus 3 equals 0, the entire thing will equal 0. So let's solve here. Move the 3 over and then divide by 2. We get x equals 3 over 2. So that is going to be our sole restriction here. So our simplified rational expression is negative 1 over 2, but x cannot equal 3 over 2. Because if it did, at this step, we would have a denominator equal to 0. Here's one final rational expression we'll look at for this lesson. Let's express y squared minus 8y plus 15 divided by y squared minus 7y plus 10 in its simplest form. And then don't forget to state the restrictions. No matter how tempted you are, do not, please do not cancel or reduce this y squared with this y squared, or this y with this y, or this 15 and 10 and reduce it to 3 and 2. You cannot do that. The reason is we have things that are adding and subtracting, which are preventing you from canceling top and bottom. So our only solution here is we need to factor. Looking at the numerator and looking at the denominator, both of these are simple trinomials. So we're going to be factoring them as simple trinomials using the sum product method. So let's look at the numerator first. We need two numbers which would multiply to positive 15 and add to negative 8. Can you find those two numbers? You'd be correct if you realize that those two numbers are negative 3 and negative 5. Both of them will multiply to positive 15, but they'll add to negative 8. What about the denominator? What are two numbers that multiply to 10 and add to negative 7? Well, you'd be right again if you found the numbers were negative 2 and negative 5. Well, this is now nice and easy for us to reduce. We have four different factors which are all multiplying and dividing, so they can cancel if we see things that are exactly the same. The y minus 3 and y minus 2 are different, and please don't cancel a y with a y. You can't do that within the brackets. But this y minus 5 and this y minus 5 are exactly the same, so we'll cancel those. And we're just left with y minus 3 over y minus 2. Again, do not cancel those y's. We are actually, in fact, done. There's nothing else we can do. But we're going to look at our restrictions. And so look at the point prior to us canceling, and we see the two brackets here on the bottom. Well, what would make, or what values of y would make either of those brackets equal to 0? We can sort of see by inspection that in the first bracket, if y equaled 2, then that bracket would equal 0. So we want to restrict that number. And we can also see that if in the second bracket y equaled positive 5, that would cause that bracket to equal 0. So we want to restrict that value as well. And there you have it. When we want to simplify rational expressions, remember, we want to see if we can factor the numerator and denominator so that we can reduce. We're going to reduce as much as possible, and then we'll state any restrictions on the variable that's in the rational expression that would cause the denominator to equal 0. We can't have the denominator equal 0, as that would make the expression undefined.